Hello friends, today we are going to learn single chip buck converter. The single chip buck converters means there are entire section in the single chips like we seen the 3 volt and 5 volt sections in our previous videos. There we saw the traditional power supply like this. In this sections the 3 volt and the 5 volt is a single chips is here, plus the two MOSFETs are used for the buck converters. So these chips have basically four parts like two linear regulators and two buck converter like this. If I divide chips in the four sections like this, then the 3 volt linear and the 5 volt linear, 3 volt buck converters and the 5 volt buck converters. So that means there are four chips in a single chips fabricated in the single chips. These are the two MOSFET for the switching purposes. So when the supplies goes inside, that is 19 volt, then the 3 volt and the 5 volt, that is called the VRG3 and VRG5, or it's called LDO03 or LDO05. This is a linear regulator. There are basically two types of regulator. One is called the linear regulator and another is called the buck converters. The linear regulator circuitry is basically used for the low current devices, and the buck converter circuitry is used for basically for the high current devices. Like when our laptop is switched off, that means only the SIO need the power. That time SIO get the linear regulator. That's like require very less power, something around 10 to 20 milliamperes power. So the linear regulator works. The linear regulator is something like a single chips, is a single component, and the buck converters is like there are so many components are involved to generate the power. Okay. So in this previous classical model, in the previous model, this 3 volt and 5 volt sections are in a single unit. Like there are single chips which have the four chips incorporated into the single chips, and these two flying MOSFETs are here. But in the newer laptops, this chips is divided. The 3 volt and 5 volt section is divided like this, and this MOSFETs also included into the chips like this, and it will like this, it will like this. So that means is now 3 volt is a different section, the 5 volt is a different section. That means there are two chips, one chips for the 3 volt which include 3 volt linear regulator and 3 volt buck converter output, and another chip is a 5 volt, include the 5 volt linear regulator and the 5 volt buck converter output. Okay, so we'll see how this chips works and how to test this test point and where these supplies are going. So this is a basically a single chip buck converter. We are seeing there are two chips. This one is a chips and another is a this chips. There are two chips. The number is SI820B SYB8208B and SY820BC. The C indicates for the 5 volt and B indicates for the 3 volt. There are basically different companies also making this 3 volt and 5 volt chips. The power supply chips made by Maxim, Texas Instrument, Richtex and Intersil. So these are the four main manufacturers who making this power supply chips for the buck converter chips. So there are so many chips, but more or less all the concepts are the same. So now we'll see how this chips works and how this voltage are generated and where these voltages are going and what are the test point if this 3 volt or the 5 volt is not coming, and then what will be the effect on the laptops and how to diagnose the chips. Okay, so we can see there are two chips on our screen. One, this chips is for the 3 volt section and another is just chips for the 5 volt sections. My adapter input voltage coming from here that is from my battery charging section or the adapter input section, that may be 18 volt, 19 volt or 20 volts, depend model to models. So this volt will come like this, and it goes to this both chips, this 18 volt or 19 volt which is coming from the adapter input section. It will goes to this volt in pin, okay, where it will goes to this volt in pin. It's called the V in pin. Okay, so you have to check the V in pin, the adapter input voltage. That is number one. And number two, once this chips get the input, this chips is ready to work. And you can see there are two enable pins here. Enable 1, enable 2, here also enable 1, enable 2. This section is for the 3 volt section, and this section is called the 5 volt sections. Okay, so these are the two different 3 volt and 5 volt sections. Okay, so to get the output, there are two outputs. One is called this LDO output and another is called this buck converter outputs. The buck converter output use the coil. This coil can't be incorporated into the chips, so that is why the coil and the capacitor is outside the chips. And all the two MOSFETs, which is a switching purpose, that incorporated into the chips, that is inbuilt into the chips. Okay, and plus the linear regulator also there. That means in this particular chips of the two sections, one is called the linear regulator, that is a 3 volt linear output, and another is a buck converter, which include the chips and two MOSFET, which will drive this coil and then output to this capacitor. Okay, so this 3 volt linear voltage will goes to this SIO chips, and this 3 volt buck converter output will goes to this different chips, like it goes to the BIOS, PCH, LCD, Wi-Fi section, network section, audio section, and there are so many sections this voltage will goes. Now what will happen if we apply this 18 volt or 19 volt to the chips? Okay, now here are the two enable pin, enable 1 and enable 2. This enable 1 is basically for this linear regulator outputs, and enable 2 to turn on this pulse width modulator or the buck converter output. Okay, so here is a resistor. My 18 volt is here. My 18 volt or 19 volt will be here, and so it will be drive from here. It will like this, and here will generate something around a 3 volt. Okay, so this is a 3 volt will be generated. Once it get the 3 volt enable signal, then this chip will drive 3 volt linear output. Okay, it's called the 3 VLP output. So you have to check on its LDO pin or it's a 3 VLP pin, 3 volt, and this 3 volt goes to the SIO VCC pin or standby pin. Okay, so you have to check this voltage. If this voltage is coming, then its linear circuitry is working. That I already told you that the linear circuit is basically a single chips, like it's a drive low current. Okay, so those devices require a low current. For that the linear circuitry is used, and the buck converter circuit is basically used to drive the high current circuitry. Okay, so my laptop is off now, so my SIO should get this 3 volt from this section. If this 3 volt is not coming to the SIO VCC pin, then you have to check this 3 VLP output, and if it's not coming out, then you have to check the enable pin. If the enable pin is not coming, then you have to check this particular resistor maybe open, and if this both voltage is coming, like enable is coming and voltage input, that is 18 volt, is also coming, but this output step number 3 is not coming, then this chips may be faulty. So you have to replace the chips and check. Okay, so in 5 volt section also the same thing. This 18 volt will drive here, it's give the enable, then this 5 volt will be generate like this. Okay, so next is, once the SIO get the power, when we turn on power button, SIO get the power button when it's turned on. So SIO drive this enable signal, and this enable signal will be a 3 volt. Okay, so once this drive, this enable signal, buck converter start to switching this both the MOSFET and this AC pulsating voltage will be drive coil this coil, and the 3 VLP, or sorry, the 3 always voltage will be generated. This 3 always voltage will be generated. Both are 3 voltage. You can see here, this is also 3 volt and this is also 3 volt. But this 3 volt is going to the SIO before power button on, and this 3 volt will generate after power button. Okay. So this 3 volt goes to the BIOS, PCH, LCD, Wi-Fi, network, audio, and there are so many other sections also. Whomever want the 3 volt, this 3 volt is going from this section. It's going to the even RAM also, RAM, SPD chips. Okay. So once this buck converter 3 volt output is stable, then this chip will generate one signal that is called the power good signal. Okay. This 3 volt will out. So it's called the power good signal. The power good signal indicate that this particular section or this entire sections is working fine. So if you check here, a 3 volt is coming out, that means this entire chip is working fine. Okay. So similarly this 5 volt is also generate. Once it get the enable signal, then the start, the pulsating AC will be generated, then this 5 volt will be generated. This is a 5 volt always voltage, and it goes to the hard disk, DVD writer, fan, and USB. And once this voltage is stable, then the power good output will be there, that is a 3 volt. Okay, so friends, in this way this single chip buck converter works. In newer models like from 5th generation onwards, the same concept are used in most of the laptops. So if your SI is not getting the power, if SI is not getting the 3 volt, then you have to check this single chips buck converter circuit. Okay, now we'll see how it works, how it will looks in the schematic diagram. So this is a schematic diagram. So this is a schematic diagram for this. This is for the 3 volt. You can see here, this is my VV in pin number 8. So here you'll get 18 or 19 volt, which is coming from the adapter. Then this is the enable pin. This is called the LDO enable pin number 3. Once it get the enable, then the linear 3 voltage will be generated at pin number 5. You have to check pin number 5, 3 volt, and this 3 VLP voltage will goes to the SIO. Okay, and then this another enable signal is there, always enable. Once this always enable get, that is a 3 volt, is get the enable signal, then start buck converter, and buck converter pulsating AC will be generated to this coil, this PL401-402 coil, and then the 3 volt always voltage will be generated. Okay, here is a 3 VL always voltage, and this 3 volt always will goes to the BIOS, LCD, and rest of the section. So similarly this 5 volt section also work in the same manners. It works also on the same manners, same inputs. Enable 2 inputs, one enable for the buck converter, another enable for the linear regulator. It starts generating the 5 volt. The pin number 7 you will get a 5 volt here at the 5 volt chips, and when it start the buck converter you will get a 5 volt here. So like that. So these are the pins you have to remember, and the steps you have to remember when you checking the actual motherboard. So friend, in this way the single chips buck converters works. So thank you very much.